We're looking at quadratics. We know that in general that these two values are the solutions to when y is equal to 0. In other words, the x-intercept is when y equals 0. So if we have y equals ax squared plus bx plus c, and we want to find those 2 points, we just put y equals 0, and then we've got a quadratic equation where everything's there is equal to 0. We know from the quadratic formula that x equals minus b plus or minus the square root b squared minus 4ac all over 2a. Okay, so that gives us our two values here. We have a number of scenarios. This is all well and good to be able to work out the square root of b squared minus 4ac. If that turns out to be positive, then we're going to get two values. What happens if this turns out to be 0? Well, we only get one value, because the square root of this will become the square root of 0. You just get minus b on 2a. And the third scenario is what happens if b squared minus 4ac turns out to be negative. Well, then we don't get any real solutions, so it won't cut the x-axis. So this b squared minus 4ac is an important quantity to work out. It's so important that it gets its own name. It gets its own name, and it's called the discriminant. The discriminant, and it determines how many times the graph is going to cut the x-axis. So, summarising, if b squared minus 4ac is positive, so you work it out and you get a positive quantity, then you can work out the square root. You'll get two answers, plus or minus, and that's minus b plus, and then minus b minus over 2a. So you get is positive, then you get two solutions, and in this case you get two x-intercepts. If b squared minus 4ac is 0, could happen that b squared, when you square it, it's exactly the same as 4ac. Then you get x equals minus b on 2a. That's the only solution, so you only get one solution. And so you get one x-intercept. Now you say, well, graphically, what does that look like? Well, if you had a situation, it could look like that. So you only get the one point where it actually, so it's actually at a tangent, or it could have looked like that. Okay, so that's when b squared minus 4ac is equal to 0. If b squared minus 4ac is negative, we get a negative quantities, and as you know, in the real number system, it's all right in the complex number system that we can get the square root of negative numbers, but in the real number system, which is the xy plane, no solutions. Can't have the square root of a negative number in the real number system, and there are no x-intercepts. And graphically, what does that look like? Well, you get something like that, or something like that, anything or something like that. So that those graphs are never going to cut the x-axis. So the discriminant is simply b squared minus 4ac. So given an equation, 2x squared minus 3x plus 6 equals 0, we know that a is equal to 2, b equals negative 3, and c equals 6. So b squared minus 4ac equals, b squared is negative 3 squared minus 4 times 2 times 6 So it's 9 minus 4 2s are 6. So 4 2s are 8 times 6 is 48. So that's equal to negative 39. So in other words, this equation here is never ever going to cut the x-axis. It'll cut the y-axis at plus 6, but it'll never cut the x-axis because we've got the discriminant is equal to negative 39.